Hello class, this is a problem from our Chapter 8 homework, and this is a review problem number 15. So what we're being asked to do is to solve this this equation that they got for us for PMT. So this is what we're trying to isolate, and that's proving, the way the question reads, that proves, or just basically deriving where the payment formula comes from. So you've done something like this before. If you recall from chapter 6.3, we solved a formula for a variable. So we're trying to get that p by itself in this variable from our notes before, and then we moved stuff over to the other side and eventually got the p by itself. Okay, it was originally solved for t, and we did some stuff to get it solved for p. And then if you take this, another problem from the chapter 6 homework set, you had a problem similar to this. We had a fraction being multiplied by x, like 3x over 2 is the same thing as 3 halves times x. So anyway, that's the same thing as a fraction times x. And you know, how did you solve that? Well, you moved all that stuff over, and I want you to see this step. You add 2 to both sides, and we've got 3 halves x is equal to 12. Now, this is something almost identical to what we have here. And you're thinking, that doesn't look anything like what we have here. Well, it kind of does. If you think of this as a 12, and you think of this, all this right here, this fraction, as 3 halves, and this PMT as the x, the thing that we're trying to isolate, then this very much looks like that. 3 halves x. Now, how did I solve this back before in chapter 6? Well, I took the reciprocal, whatever the fraction that's being multiplied by the variable we're solving for, we multiply both sides by the reciprocal of that thing. So 2/3, 2/3, and on the side with the variable, the 2's cancel, the 3's cancel, and all we're left with is x. Alright, and on this side, the 3 goes into the 12 4 times, and 4 times 2 is 8, and there was our answer. You can go back and check it and verify that it works. Well, this is very similar, only we don't have numbers, we have a formula. So it's kind of like a hybrid of this problem and this problem. There's all just letters, and here there's a fraction involved. So what are we going to do? Just like before we cleared that fraction, we're going to clear this fraction. We're going to clear the left and right side by multiplying by the reciprocal. The reciprocal of that big complicated thing is just flipping it over and putting whatever was in the top down in the bottom, and then whatever in the bottom up on the top. Alright, now remember, whatever I multiply by on the left, I have to also, multiply by on the right, I have to also multiply on the left. But look what happens over here on the right, everything cancels. So I end up with an r over n on the top, and then this 1 plus r over n to the nt minus 1 in the bottom. So I end up with p, and the way they have it written in the homework problem, they put the r over n in here second. So in your homework, they'll have like an answer box, like around here, and around here. Okay, but just notice what I want you to see here. This is what was there to begin with. And there it is. There's the p. There's the 1 plus r over n to the nt power. So that was there to begin with. And what we just brought in was this r over n that we put in the top right here. And then all this down in the denominator that we put down there. Okay. Right, now this is what they'll ask you to do next. They'll say, alright, now get rid of some of this stuff, meaning we're going to divide the top and bottom by the same thing. Remember, as long as you do the same thing the top and the bottom, it's perfectly fine. It's equivalent to 1. So we're going to divide the top and the bottom. Alright, now what's going to happen here is when I divide this and this are going to cancel. But over here in the bottom, when I divide, I have to kind of distribute it through. So it's this over top of this, so that will cancel, but then we're going to have a minus 1 over this. Okay, so we're basically done. So if you remember the other side of this that we haven't quite isolated yet, this is PMT, so it's by itself. All this stuff that we've been simplifying is opposite the PMT. So we're saying PMT is equal to this, and that's why we have PMT equals P R over N divided by 1 minus, but then we have this with looks like this is back up at the top again. But notice this has got a positive exponent, the NT here, and this has got a negative exponent. And if you remember, a negative exponent is like a reciprocal. So for instance, 2 to the power of, or raised to the power of, negative 3. Alright, that's the same thing as 1 divided by 2 raised to the positive 3. Alright, a negative power, it just basically means reciprocal. So for instance, 5/8. If I raise that to the negative 1 power, that's what this button does on your calculator. 5/8 to the negative 1, that's that number. And if I started with 8/5, which is 5/8 flipped over, I get the same thing. So a negative power just means reciprocal, and then raise it to the positive power once it's flipped over. So that's just another way to write this piece right here. I could just rewrite 1 over R plus 1 plus R over N to the positive NT. I can get rid of all that. Instead of having a fraction, I could write it as just 1 plus R over N, and then just use a negative power. Alright, and there's what it's asking us to do. So we've proven what they've asked to do. Now let's look again at the process. How do we do that? We multiplied by the reciprocal, just like we did with the problem back in chapter 6. After we multiplied by the reciprocal, we had this ugly beast right here, the P R over N, 1 plus R over N to the NT, and then an extra one down here. Okay, keep your goal in mind. What do you want this to look like? This P R over N. There is no extra 1 plus R over N to the NT, so we need to divide it away. Now as long as we do it to the top and bottom, that checks out. Okay, everything's fine. It's kind of like simplifying a fraction. 6 over 9. If I divide by 3 and divide by 3, I get 2 over 3, and they're equivalent, right? It works the same way with expressions, meaning that there's, formulas and letters and everything involved. So I divided the top out and divided the bottom out by distributing it through, and I was left with that expression that we simplified to this by using that property of exponents, where we can just get a negative exponent.